powerful tools exist that allow us to capture and inspect all frames that come through a particular network interface. Wireshark is perhaps the most widely known, and it's freely available and it's a good tool to use. However, if you were to try Wireshark and just turn it on to to capture and inspect everything that's coming in through your wireless network interface card, you might be disappointed because you might find that you're only seeing traffic that's going between your access point and your computer. You're not seeing other traffic between your access point and other devices, and you're not seeing traffic that is going on between surrounding nearby access points and those devices that are connected to those access points. Why is this? Well, it's actually a good thing for most of the time, because in most normal ways of using Wi-Fi, you don't want to be bothered by frames that are not meant for you. You just want to be, let's say you're browsing the web or whatever, you want to be seeing things that are meant for you. And so it's a good thing. And Wi-Fi is designed to filter out most of the other signals that are coming in, and so you only get what's meant for you. That's good for normal modes of operation, but when you're trying to do Wi-Fi penetration tests, you actually would prefer to see more of what's going on. You want to see more of the frames, even frames that are not meant for you. You want to see what's going on between your access point and other devices, and surrounding nearby access points and other devices. In a sense, you want to be a busybody, so to speak. Well, so what's happening? I mentioned that all these other frames are being filtered out. So how is that happening? We're going to go through some of the ways in which things get filtered out, and then we'll talk about a couple of modes where you can set your network interface card to these modes if your network interface cards support these modes, and you'll be able to actually then capture more of these other frames that you would not otherwise be able to. Let's look firstly at the physical layer, because some of the filtering happens at a physical layer, some of it also happens at a MAC layer. So the first thing perhaps that we would think of is that, well, certain access points are too far away, so by the time the signal gets to you, it's very weak, and so you cannot receive. So physical distance is the first reason why some frames are not arriving at your receiver. Now, even if physical distance is not an issue, so you might be getting reasonably strong signals from an access point, you might be listening at a different frequency band from the transmission. So let's say you're listening at 2.4 gigahertz, it's transmitting at 5 gigahertz. You also don't hear what it's transmitting. So more frames get filtered out this way. Now, even if you're using the same frequency band, so you're listening at 2.4 gigahertz, but the access point might be transmitting on a different channel within this band. So let's say you're listening to channel 1 at 2.4 gigahertz. The access point might be transmitting at some other channel, like channel 6, 8, 9, 11, whatever, that's not overlapping with channel 1. Then you don't hear it either. Besides all these, in a sense, physical constraints having to do with physics, there's also the transmission scheme, the frame format and the modulations, and that has to do with the physical layer alternative that is being used. As mentioned earlier, there's various alternatives like 802.11a, B, G, and AC, and so on, and not all devices support all of these alternatives. So, for example, you might have your network interface card that only understands A, B, G, and does not know how to interpret signals that are encoded for 802.11n or 802.11ac. So if you have access points transmitting or devices transmitting in these formats like 802.11n, you will not be able to understand them. Additional filtering at the physical layer can happen due to errors in the reception. So your network interface card, for various reasons because of noise and interference, might detect some bits wrongly. Therefore, Wi-Fi has a built-in CRC test that helps the network interface card to detect some errors. So it might detect it because it fails a CRC test, and then that whole frame gets dropped. That's also something that can happen. Now, closely related to dropping of frames is encryption or ciphering. So even if a frame doesn't get dropped, it might not be understandable because it's encrypted and you don't know how to decrypt it. So these are all ways that then things get dropped or hidden from your site. In the case of encryption, if it passes through, you might still see it in Wireshark, but you might not be able to understand it. It might look encrypted and you don't know what the frame contains. Besides the physical layer, there is also filtering happening at the MAC layer. So now the subset of frames that pass through the physical layer filtering and come to the MAC layer then get further filtered based on things like the destination MAC address. So usually you only are interested in frames that are addressed to you. So the network interface card checks the MAC address and sees if the destination is not you, it's an unknown MAC address. It also discards the frame. Furthermore, you have to be associated with a BSS, and so it's also filtering by the BSS that you're associated with. And because of all of that, generally then you will not really be seeing much unless you turn on one of these other modes, not the normal mode, but monitor mode or promiscuous mode that are designed to allow a network interface card to pass up more frames to the application layer so that an application like Wireshark can then let you inspect these frames. We go to promiscuous mode first. This applies to both wireless and wired LANs in the sense that the network interface card that is in promiscuous mode will just pass up all frames, even those where the destination MAC address is a different device. For the case of wireless LANs in promiscuous mode, they have to be associated with a BSS to see other traffics in the BSS. Therefore, this might not be so powerful in a sense because you have to be associated with a BSS. It's kind of like being plugged into a wired LAN. So when you're associated, then you belong to that wireless LAN, and then you see all the traffic in it in promiscuous mode. Even more powerful though is monitor mode, where you don't even have to be associated with BSS as long as a frame passes in and you can detect it. Just go ahead and send it up to the application layer. Sometimes it might even be failing a CRC test and be corrupted, but well, it can still be passed through. So monitor mode is very powerful, but only some network interface cards support it.